All right, today's lesson is 5-6, direct variation, and we have two different objectives for today. The first one is to be able to identify and graph direct variation equations, and then we want to be able to write and solve direct variation equations. All right, you should have out your notes handout for 5-6. We're going to go through and fill those in. This first part, the very first box, we're going to fill in a few things here. It says direct variation is y equals kx, and k is your constant of variation. All right, so again, we are filling in this very first thing. The k is what we call the constant of variation. And again, it's just a constant number, so we're going to put a number in front of that x, and that's going to be our k. It is a linear relationship. So linear relationship, meaning that whenever we graph, it's going to form a line. With it being direct variation, it's always going to pass through the origin, which is the point 0, 0. So it's always going to go through that point 0, 0. So when we go to graph, we're going to start with 0, 0 each and every time. And our slope for direct variation, and it has a slope of k. Okay, you guys are usually probably used to seeing slope as being m. When we're using direct variation, our slope is called k, which is our constant of variation. But again, it is the same thing as your slope, or it is your slope for this one. All right, make sure you have that all written down on your sheet before you move on. All right, so this next one, our directions say, can you identify direct variation equations? Remember that direct variation is y equals kx. It wants us to tell whether the equation represents a direct variation, and if so, it wants us to identify that constant of variation, or the k. So we're going to look at part A right here. And it says y equals 3x. If you look at that, that looks very, very similar to y equals kx. So this one is a direct variation because it's y equals some number x, and that's what direct variation is. So for this one, we're going to put yes. And it says if it's yes, to go ahead and tell what that constant, or the k, is. So we're going to say k equals 3. And k, or the constant of variation, is just that number in front of the x. So now we're going to look at B. It says y equals 3x plus 1. This one is not a direct variation because of the plus 1 on the end. Direct variation doesn't have a plus or minus anything over here. Plus, if we were to graph this, it would not go through the origin since its y-intercept is at 1, so we're going to put no for this one. And the reason that it's no is that it does not pass through the origin. All right, then we're going to look at C, y equals x squared. This one is not a direct variation because up here the x is not being squared. Plus we know that x squareds give us a U shape and not a line. So our answer to this one is no. Then we have D, y equals 7. And y equals 7 is also a no, because again there's no x here, and for it to be direct variation it needs to be y equals kx, and there is no x, so this one is no. Plus it also does not pass through the origin if I were to graph it. Now the one right here with E is a little bit more difficult to tell whether or not it's actually a direct variation. We actually have to get the y by itself first in order to tell. So to get the y by itself, we're going to add 4x to both sides. And we get 3y equals 4x. And you can put plus 0, but you don't actually have to. And then I'm going to divide both sides by 3. So we actually get y equals 4 over 3x. So if we look at this, it looks like y equals kx. So it is y equals some number x, which is a direct variation. So the answer to this one is yes. We're going to say yes. And it says if it's yes, to go ahead and give the constant of variation. So here our k, again, is just the number in front of x. So that's 4 over 3. And again, those k's are the same thing as our slope. Go ahead, take a minute, make sure you have all of that written down before you move on. All right, we're now on to number 2. It says name the constant of variation in slope. for the graph and then write the equation for the line. So here basically all we're wanting you to notice is that our slope and our k are the same thing. So we're going to write k equals, and we're going to write m equals. Both of those, again, mean slope. However, k is specifically for constant, or is specifically for direct variation equations. So we're going to find the slope here. So I'm going to pick 2 points on my graph, and I'm going to count the rise over the run. So remember that it is rise over run. This one's also rise over run. So I'm going to pick this point and this point, and to get from here to the point up there, I'm going to have to go up 2. So that's a positive 2 because I went up 2. And then I'm going to have to go to the right 1. And since I had to go right, that's also a positive 1. So my rise over my run is 2 over 1. So that means my k and my slope, or my m, are both 2 over 1, which is 2. On your work, or on your assignment tomorrow, it's going to ask you for the slope and the constant of variation. And again, just remember that those two are exactly the same thing. So on your assignment tomorrow, you're going to say k equals whatever number that slope is, and m equals whatever number the slope is. All right, now we're going to actually write the equation for the line. And since it's y equals kx and k is 2, we say that the equation is y equals 2x. So that's our equation, our direct variation equation. Make sure you have that written down before you move on. All right, I'm on to number 3, and again it says name the constant of variation and slope for the graph, and then write the equation for the line. So again, slope and constant of variation are the same thing. We just call the constant of variation k, and we call the slope m. There again, our rise over our run. So here again, I'm going to pick 2 points. I'm going to count the rise over the run. I'm going to pick this one and this one. I'm going to say, how do I get from here to here? Well, I have to go down 1. So since I went down, that's negative. And then I'm going to have to go to the right 1, 2, 3, 4. And since it's to the right, that's a positive 4. So my rise over my run here is negative 1 over 4. For both my k and my m. So my slope and my constant of variation are both negative 1 over 4. Again, we like for that negative to be out in front. Okay, so there's my k and my m, or my slope and my constant of variation. That was the first thing they asked. Now they want us to write an equation, and again it's y equals kx, so I'm going to put in negative 1/4 for my k right here. So I'm going to say y equals negative 1/4 x. And there's my equation for that line. Go ahead and make sure you have all that written down before you move on.
All right, so we've looked at identifying direct variation equations, and now we're going to look at graphing them. It says graph the direct variation functions, and they've given us here for number 4 y equals negative x. So we have to determine what our k is first of all. And you understand that before, in front of a variable, when there is nothing else there, we have an understood 1 there. So this is the same thing as saying y equals negative 1x. If I have to write negative 1 as a fraction, I'm going to write that as negative 1 over 1x. So that is going to be my direct variation equation here, is y equals negative 1 over 1x. Now, I am going to start at the origin, and I'm going to go ahead and make a point here at the 0, 0. So do that now on your graph. Start at the 0, 0. We always start there. And I'm going to move my slope, my k, which is negative 1 over 1, or 1 over negative 1. So the first time I'm going to come down 1, which is my rise or fall, and then run 1, which is going to put my point here. I'm going to come back to my 0, and I'm going to do the opposite. I'm going to go up 1 and back 1. So my slope is positive 1 over negative 1, or negative 1 over positive 1. And so I've made those 2 points here, and now I'm going to draw a line to connect the dots. Again, make sure that your line continues on beyond the points, that it doesn't just stop there. You should have arrows. It's a line. It continues on just like this. So you need to go ahead and graph that line on your own graph, and that is the direct variation equation graph for y equals negative x. Make sure that you have all that down before you move on. All right, now we're going to look at number 5. Number 5, again, is telling us to graph the direct variation function, and it says y equals negative 3 over 4x. So again, this one is already in the right form. I have my y equals kx, so I'm just going to write over here that k equals negative 3/4, because that's what I'm going to move. That's my slope. So I'm going to make a point at the 0, 0, and you need to do that as well. Make a point at the 0, 0. And I'm going to first do the negative 3 over 4. So I'm going to say I go down 3, 1, 2, 3, and then I run 4. 1, 2, 3, 4, and that's where I make my point. Go back to your origin, and this time I'm going to treat it like it's 3 over negative 4. So I'm going to go up 3, 1, 2, 3, and back 4. 1, 2, 3, 4. Now I'm going to connect my dots by drawing a line that passes through all 3 of them. And you should do the same thing on your own paper. And that is the graph for the direct variation function y equals negative 3/4 x. Please make sure that you have all of that down before you move on. All right, so let's look at number 6. The first thing you're going to do here to graph this direct variation function is you're going to put a point at the origin. Our k here, or our slope or constant of variation, is 2 over 3 because it's y equals kx, so this is my k. So it's 2 over 3, and I'm going to go up 2 over 3. 1, 2, 3. Again, it's rise over run. So here, I'm going to come back to my point of origin, and I can also go down 2 and back 3. 1, 2, 3. Because that would mean negative 2, negative 3, which would in turn become positive 2 over 3. I've made my 3 dots. Now I need to get a ruler and graph my line. Again, if you don't have a ruler, it's no big deal. Just use a straight edge off of something. Make sure that you connect your line through all 3 points. Put arrows on either end of your line to show that it continues on. And make sure that you have all of that down before you move on. You can pause the video now if you need to. All right, so we've looked at how to identify and graph direct variation equations, and now we're going to look at how to write and solve direct variation equations. All right, so let's look at number 7, and this is the first one that you've seen like this, so don't freak out by looking at it. It says the value of y varies directly with x, and y equals 3 when x equals 9. Find y when x equals 21. We're going to break this question down and look at all the different parts of it, and then we're going to make sure that we do parts A, B, and C on our answer. So if the value of y varies directly with x, then that just tells us that yes, it is a direct variation equation. That's all that's telling us. It varies directly with x. That means yes, it's a direct variation equation. When y equals 3, when x equals 9. So we have to name the constant of variation, write a direct variation equation, and solve for the indicated variable. The first thing we're going to do is say y equals kx. Okay, that's a direct variation equation. They've given us y is 3 when x is 9. So that means 3 equals k times 9. I've plugged that into the direct variation equation. In order to name the constant of variation, I have to solve for k. So this is no different than saying 3 equals 9k. That's how you're used to seeing it, so it may make more sense to see it like that. And that's just telling me that I have to divide both sides of the equation by 9 in order to get the k by itself and to solve for k. So these 9's cancel, and this gives me 1 over 3. It reduces down to 1 over 3 equals k. So that is my A. Part A said, name the constant of variation. So I'm going to name the constant of variation k equals 1 over 3. That is my constant of variation. I've done part A. Part B says write a direct variation equation. Well, that's really simple. All I have to do is take the information that I've been given, which is, or that I have found so far, which is that k equals 1/3, and plug it back into y equals kx. So y equals 1/3 x. So this is part B. Y equals 1/3 x. Now, I have to solve for the indicated variable. What that means is that I come back up here to where it says find y when x equals 21. So they want me to plug that in to this direct variation equation and solve for y. So part C is to solve for y. Y equals, again, I'm going to plug in that k that I found and the x that they've given me, which is 21, to solve for y. Now you're going to type this in your calculator, 1/3 times 21, and it's going to give you 7. So y equals, and again, multiply that together, and it's going to give you 7, and y is solved for. So C is y equals 7. So again, my parts here, A, B, and C. You will have to do all 3 of these parts on your homework problems or your classwork problems tomorrow in class. So make sure you understand all 3 parts of these are required. Now Mr. Beatty's going to look at the next few examples with you.
Alright, so we're doing another one of these fun 3-part questions. Let's see what we got here. The value of y varies directly with x. Okay, stop right there. Value of y varies directly with x. That means it's one of these direct variation equations. So y equals kx. I know it's going to look like that because it says that y varies directly with x. That's what it means. It means it's going to look like y equals kx. Continue reading, and it says, and y equals 28 when x equals 7. Okay, let me plug that in. Y equals 28. So 28 equals, let me continue reading here, when x equals 7. Okay, so I know what x is. So k times 7. Alright, so I know this y value of 28, I know this x value of 7. What I don't know is this k. So to find that k, I'm going to divide both sides by 7. 28 divided by 7 is 4. So 4 equals k. And k is my constant of variation for this problem. So notice in part A, it tells me to name the constant of variation. That's what k is. So I've answered part A right here. 4 equals k. You can write it as k equals 4 if you want to be fancy. Alright, part B. We are asked to write a direct variation equation. So all that means is we're going to take that constant of variation that we just found and we're going to plug it into the direct variation equation. So we've got y equals 4 x. That is our direct variation equation. Again, all I've done is take my constant of variation of 4 and plug it into the direct variation equation. That's what part B is asking me for. Alright, finally, we're almost done. We are asked to solve for the indicated variable. And so it's asking me to find x when y is 52. So, part C, I'm going to be using that equation that I just found in part B. So we're starting with that equation, y equals 4x. I know that y is 52, so I'm going to plug in 52 for y. How do I know it's 52? Because it tells me that y is 52. Now, all I need to do is solve for x, which we can easily do by dividing both sides by 4. So that means that x is 13, if my mental math is correct. So 13 equals x, or x equals 13. Make sure I've got everything here. Name the constant of variation. We did that. We wrote the direct variation equation. We did that. And we solved for the indicated variable. Alright, we are done. Alrighty, number 9. The value of y varies directly with x. So again, that means that I'm working with one of these direct variation equations. So my equation is going to have this form right here, y equals kx. So it tells me that y equals 4.5 whenever x is 0.5. So let me plug those two values into my direct variation equation. So we've got 4.5 equals k times 0.5. We're going to solve for k by dividing both sides by 0.5. So 4.5 divided by 0.5, type that in your calculator, it will come out as 9. So 9 equals k. That is my constant of variation. And that is what it is asking me for in part A. Name that constant of variation. So you can write it as 9 equals k or k equals 9, whichever you prefer. Now in part B, we're going to write the direct variation equation. All that means is we're going to plug 9, our constant of variation, into this original formula up here. That's all we're doing when we're asked to write the direct variation equation. So we've got y equals 9x. That is our direct variation equation. Alright, in part C, we're asked to solve for the indicated variable. And that variable is going to be y. It's asking me to find y whenever x is 10. So I'm starting with that y equals 9x, and I'm just going to plug in 10 for x, and that's going to allow me to solve for y. So y equals 9 times 10, which means y equals 90. Alrighty, in number 10, we are looking at one of the real-life applications of direct variation, and we're going to be using this formula that I believe most of you have seen, D equals RT. That stands for distance equals rate times time. And that is a direct variation equation, just a very specific one. We'll be using it to solve this problem. So let's see what we got here. Distance varies directly with time. A flock of geese flew 375 miles in 7.5 hours. So that right there is enough information for me to be able to figure out my constant of variation. So I'm working with D equals RT. The distance I'm given is 375 miles, so I'm plugging in 375 for the D. Miles is a form of distance. And I'm also told that they can cover this 370 miles in 7.5 hours. So that's what I'm going to be plugging in for T. So 375 equals R times 7.5. So I'm going to be solving for my constant of variation. In this case, that is my R, my rate. So just like the previous problems, we're going to be dividing both sides by something. We're dividing both sides by 7.5. So 375 divided by 7.5, that comes out to 50. So R equals 50, and we are talking about miles and hours here, so this rate is miles per hour, and that is part A. That is my constant of variation. And just like before, the next thing we're going to do is write our direct variation equation, which just means that we're going to be plugging in that constant of variation. So D equals 50T. That is my direct variation equation. And finally, in part C, we're going to be solving for the indicated variable. Now it asked me to determine how long it is going to take for these geese to fly 3,000 miles. So 3,000 miles, that is a distance, so I'm going to be plugging in 3,000 into D. So D equals 50T, that is the equation I'm starting with. And I'm plugging in 3,000 in for the distance. And now I'm going to be able to solve for my time, T. To do that, I'm going to be dividing both sides by 50. So 3,000 divided by 50, that gives me 60. So T equals 60. And the time in this problem is talking about hours, so that is 60 hours.
Which is a really long time to be flying.
It is a really long time to be flying. I imagine they have to take several breaks. But I don't know. I'm not a geese. Or a goose. English is hard. Alright, number 11, last one. Distance varies directly with time. So this is another one of these D equals RT problems. D equals RT. Alright, it says that Sarah ran 2.5 miles in 15 minutes, which is actually a phenomenal pace. I think that's something like a 6-minute mile, which is pretty darn good. So 2.5 miles, that is my distance. So I'm plugging that in for D. And it says that this 2.5 miles, she's able to run that in 15 minutes. So I'm going to plug in 15 for my T. So 2.5 equals R times 15. So I'm going to solve for my R here by dividing by 15. And this comes out to 1/6. So R equals 1/6 mile per minute, which again is a pretty darn good pace. Alright, what are we being asked here? We're being asked to figure out how long it's going to take her to run 4 miles at this rate of 1/6 miles per minute. Alright, so I know my rate now, so I'm going to plug that in. We got D equals 1/6 T. So this is the direct variation equation I'm going to use to figure out how long it's going to take it to run 4 miles. So 4 miles, that is a distance. So that's what I'm going to be plugging into D. So 4 equals 1/6 T. I do have a fraction in front of this T here. So instead of dividing both sides by 1/6, I'm going to multiply both sides by the reciprocal. The reciprocal of 1/6 is just 6/1. So I'm going to be multiplying that on both sides. When I multiply that right side by its reciprocal, these fractions cancel. That was the whole point. So 6/1 times 4, that gives me 24. 24 equals T. And this time is in minutes, so that means that it takes her 24 minutes to run 4 miles. That is a 6-minute mile. It is very impressive. I'm too out of shape to get even close to that.